that architecture means the theoretical part, the logical part, or the software part, and the organization is the hardware part or implementation part of the computer. So please remember these two terms. One is the architecture, another one is the organization, because these two words we are going to use so many times in the next some of the other slides, and of course the entire syllabus as well, I mean the course as well. So please try to understand the two terms, architecture and the organization. Just remember, architecture is the design part and the organization is actually the physical part. Okay, we also have discussed yesterday about the principle of the equivalence of hardware and software, which is if you can do anything by the software, you can do the same task by using the hardware. And also the other way, if you can do anything by the hardware, you can also use the same thing as by the software. So that is called principle of equivalence of hardware and software. And we are going to consider two things. One is we assume that the speed of this implementation or the speed of this execution is not a concern. First thing. Second thing is we know that every software needs hardware to implement this one. So we also are not considering that software needs the hardware. We're just considering we can do the task by the software. Okay, I gave you the example about this one yesterday about the calculator. All right, so you can do, if you do it in a software calculator, you can do the same thing as a hardware calculator as well. Same as, let's say, for example, any musical instrument. We have a musical instrument physically, which is a hardware, completely a hardware. Another one, we do the same kinds of musical instrument by using the software, because you know that there are so many software instruments we have which can be very similar. That means we can produce the similar kind of sound of a drum by using a software, right? So this is just an example. If you think more, if you try to imagine more, you can do understand that it is quite obvious that anything can be done by the software. It can also be done by the hardware and vice versa as well. Fine. We also discussed yesterday about the basic components. We know that there are three basic components of a computer: input, output, memory, and the central processing unit, which is the processor. And we also know that these three equipments, or these three elements, are connected to each other by a system bus, this one. By a system bus, this one. Because these three components are separate components. Just closing the door. Okay. So as I said, that these three components are the separate elements. That's why we need to have something which can connect between each of them. All right. So that connection is called system bus. And we know that system bus is actually a combination of three bus: address bus, data bus, and control bus. Okay, so that is our full computer. If you think about more about the CPU, this is our CPU, that this is our processor. So inside the processor, we also have three basic components: our register, where we store the data; our arithmetic logic unit, where we do our arithmetic task and the logical calculation; and another one is the control unit, where we can do a controlling task. So, of course, again, we have an internal bus to communicate between each other. In this course, we just need to know until this. We are not going to discuss much more deep. That is the topic for your other course, which is the microprocessor course, which is a completely different course. That means you are going to know everything about this microprocessor in a separate course, which is a 3-credit course. All right, so that's a different story. So we are not going to discuss that much. We just need to know about the basic components and how does it work. Okay, can you remember that why we need to know all this, because this is just assembly language. It's supposed to be just coding, right? But instead of coding, we are actually learning. Till now, we are actually learning about our computer, our processor, our memory, our input output. What is the relationship between this? What is the reason that we need to know all this just to do a code? What do you think? How? Correct. You are correct. But how? Yes. Think about your C programming language. Whenever you use Java or Python or HTML, whenever you write those languages, you actually don't need to think that how many registers do you have in the CPU. Whenever you write a C code, you actually don't need to think or consider that what is the size of each memory block into your computer. No need. Right, because it's a high-level language, the rest of the task will do by your interpreter or your compiler or your virtual machine. Right, but whenever you work, whenever you try to write a code in assembly language, right, we know that it is a low-level language, so we are working on the hardware. So we need to know the hardware very well. That means your system very well. Otherwise, it is not possible to write. For example, if you don't know that how many registers you have in a CPU, what are the names, how big they are, that means what are the size of the register, of each register, how many cache you have, what is the size of the cache, how many memory block do you have, and what is the size of the memory block, what are the location of the memory. If you don't know this information, it is impossible to write an assembly language code. All right, that is actually the basic reason that we are discussing so many about our system. Because if we know our system very well, then we can write an assembly language code very well as well. That's why this is the third week. We are still discussing about our computer system. Okay, that is the reason. So please keep in mind that it is necessary, it is absolutely necessary to write an assembly language code, because I heard some of the feedback from the last year that the part of the assembly language code in the entire syllabus or entire course is very less. Very less, of course, that is true, because of this reason. Because if you don't know about your system, it is impossible. You can memorize the code, no problem with that. You can memorize the code, like math. If you have a math problem, if you memorize the solution of the math, you can do that. You can write in the exam and pass, no problem. But the problem is you cannot do that math, similar types of math, because you don't understand what you're doing. Right? So you can memorize the math. But the problem is during the exam, you cannot answer the question. During the Viva, you cannot answer the question. And your career, whenever you try to write a low-level language, you will not be able to code because you memorize. So that's why we need to do this. Okay, let's continue. So these are our main components. I think yesterday we have also discussed about the very basic about the processor, right? Yesterday we have discussed, yes, that we have a processor which can execute the instruction, and we have two types of things, architecture and organization. And we have also showed you that each processor needs to do a lot of tasks, needs to execute a lot of process. So it must have a process or a form or a sequencing technique by which it can execute the process one by one. Because I showed you yesterday, you can see in your laptop or PC as well, hundreds of processes are running at the same time, and we have only one processor. Although that processor may not be able to do multitasking, So how it can do that? So using some of the technique. All right. So that is actually the sequence of the implementing, or the sequence of the instruction. And also at the same time, for the organization, you need to know about your processor. Like, of course, as I just said earlier, that you need to know how many registers we have, what are the size of the register, what is the location of the register, something like this. All right. So that is our processor, very, very briefly. About the memory, we also discussed that we need to know about the memory size of the memory, architecture of the memory, and then, of course, the physical perspective of the memory, so that we can use it during our coding. All right. And I hope you remember that we also have discussed the memory hierarchy. So if you remember about the memory hierarchy pyramid, what is on the top of the pyramid?
A register.
Yes, the register. The register, where it is located? The register?
Inside processor.
Inside the processor, correct. What is the next one after the register? Anyone else? After the register?
Cache.
The cache memory, yes, the cache memory. After the register, it is the cache memory, correct. Do you know where is the location of the cache memory? No? It is
RAM is in cache too.
Huh? Where? If it has, because some of the processor has its own cache, we also have other cache in the motherboard and in the system as well. So let's consider the cache is very close to the microprocessor as well. Fine. Next one.
Main memory.
Main memory, correct. So main memory. After that, our hard disk. Our hard disk and the CD-ROM and everything. So different types of memory is used by different types of processor. If you can remember, in chapter number 1, we have seen that 6 types of processor is using our main memory to execute the program, whereas the RISC types of processor, they use the register to execute the program. All right. So that's why we need to know these all types of memory architecture very well, because if you don't know it, you will have some problem to write the code. Because every time you write a code in the assembly language, you must think about the location of your variable, the size or the block of your, or the segment of your memory. We are going to discuss about the segment in the next chapter, where we can see that depending on the segment size, right, depending on the block size of the memory, we do several other tasks. Okay, so that's why memory architecture and memory organization is also very, very, very important whenever you try to write any low-level language like our assembly language. Okay, let us see the next one. Next one is the input-output. So we know that input-output also have a very good responsibility. Of course, you get information from the input device, and also when after processing, you can show it, you can store it into the output device. All right, so that's why it is also part of our system. Without input-output, you cannot have a complete computer system. Right, so these are the very brief description about our 3 components which we have discussed yesterday. Let us talk about our system bus. Do you remember that why we call them it as a bus? Why it is a bus? Of course, but one where also can send from one point to another point. Instead of where, why we call them bus? Easily we can call them address where, data where, block, like, yeah, correct. I mean, your understanding is correct, but the rest of us don't understand. What does it mean? Anyone else? I'm not asking a single, anyone else, whoever, I mean, can guess that why we call them this one as a bus. Anyone? Okay, the answer is we call them bus because it is a combination. It is a combination of several wires, right? So it is not just one wire, or it is not just one part from processor to memory or memory to processor or from input output to the other two elements. It's actually the combination of several wires or several parts by which we can transfer our data or receive our data. Okay, because that's why it's called bus, because it is combination of several parts or several wire, right, by which we can transfer or receive the data. That's why it is called bus. Remember, combinedly, these three, combinedly, they call it system bus, right? System bus is not a separate types of bus. It's actually the combination of these three buses called the system bus, right? Address bus, data bus, and control bus. We know that the address bus, of course, it store or it transfer the address of the location, either it's a processor location, memory location, input output location. So just the address of the location, memory location only, nothing else. Data bus is using for transferring the original data by which you are going to process, by which you are going to execute your instruction. That is the data bus. And the control bus is, this is a special types of bus which has some controlling signal. For example, read from the memory, that is a control signal. Write from the memory, that is a control signal. Get input from the memory, get output from the memory. Right? So these are the kinds of the control bus. There are specific names we will show you. Those kind of signal, control signal, is used in only the control bus. Whereas combine all of them, they are system bus. Okay. There are very interesting about this bus. What is interesting thing is about the address bus. Right? Look at the address bus. As I told you that this is used only for the locating the memory. All right. So processor use this bus to locate the memory location or to find the data. And this is the address. Let's find the data from that memory location. Okay, that is the responsibility of address bus. The interesting thing is the width of the address bus represents the maximum size of the memory. Let me tell you again. The width of the address bus represents the total maximum size of the memory of your system. For example, if you have 8-bit width in the address bus, your maximum memory will be 2 to the power 8, which is 256 bit, right? That means if your address bus is 8-bit width, that means you can send 8-bit at a time, then your maximum size of the memory will be 256 bit. If your address bus is 16 bit, it will be 65 kilobit of memory you can use maximum. Let me show you. 2 to the power 16 is 65,000. That means you have 65. That will be the maximum memory size you will have if your width of the address bus is 16 bit long. Right? If your address bus is 32 bit long, you have maximum 4 gigabyte of memory. That's why previous computers and previous processors, which are 32-bit processor, more than that. That's why whenever I use my first computer, it was 128 megabyte memory only, because my processor was Pentium 4 and that was 32-bit processor. Okay, that means the address bus of those kind of system is actually only 32-bit. That's why you cannot have more than 4 gigabyte of memory of those kind of system, which is very old technology, by the way. Nowadays, everything is now 64-bit. Look, if your address bus is 64-bit long, it will be very, very, very large number. It is like 2 terabytes almost. It is actually tera. 1, 2, 3. Yeah, almost tera. So if your address bus is 64-bit width, remember it is the width. That means 64-bit you can send and receive at the same time. So if you have 64-bit width of your address bus, you can use maximum of 1.8 tera, or let's say very nearly 2 terabyte of memory, which is very huge. By the way, it seems like it is very huge nowadays, but maybe in recent, after 15, 20 years, obviously you are going to use your terabyte memory. Same as my experience. When I used my first computer, it was 128 megabyte of memory. And I was so happy. I told you that, right? I was so happy that I have so big memory. I never, ever, ever imagined that after how many years? 20 years. After 20 years, I have 16 gigabyte of memory. My computer has 16 gigabyte. I never, ever, ever imagined even that it will be possible that my computer in future, it will be 16 gigabytes of memory. So you also cannot imagine maybe that your memory size can be terabyte very soon. Why not? Why not?
Yes, sir.
It is, I mean, it will be amazing, and it is impossible right now, maybe in your imagination, but wait for 5, 10 years. Not within 10 years, you can see that your desktop PC will be also terabyte memory. Also, I said that my hard disk was 40 gigabyte at that time. 40 gigabyte hard disk is almost very, very high end. At that time, there was 80 gigabyte memory hard disk, but I bought 40 because it was very expensive. So I never, ever, ever imagined that it can be terabyte. Now my external hard disk is 2 terabyte. My smaller laptop, which is also have 2 terabyte. But just think about it. 20 years ago, it was 40 GB, my PC. I was so happy that I was thinking that what can I do with that much huge space? So you cannot imagine that what actually is coming. So the point is that now everything is now 64-bit. I think you know that nowadays, most of the processors are now 64-bit. Most of the software are now 64-bit, although we have 32-bit version as well, but most of the manufacturer, most of the software companies, they actually now shifting from 32-bit to 64-bit because they're trying to remove all the 32-bit processor and 32-bit device and everything because it's very old technology and very slow. You cannot use them properly. You need to transfer from 32-bit to 64-bit. So it's a problem, right? So everything is now 64-bit. Your computer, your processor, your data bus, your software, your operating system, most of your software, everything is now 64-bit. Whatever software you try to download, most of them are 64-bit. Okay? Because of this reason. Late. Anyway. Do you understand about the address bus, the examples I have just given? Any question? It is written on the next slide, maybe, and in the book also. Yes, this one, the width of the address bus determines the memory addressing capacity. Right? Any question? Think about it first, and then you can have question. What do you think that why there is a relationship between the address bus and the size of the memory? What will happen? What will happen that if we have more memory than the address bus capacity. If we have, let's say, 32-bit, and we have more than 4 GB of memory, let's say we have 8 GB of memory, what will happen? We have 32-bit address bus, but we have installed 8 GB of memory. What will happen? The system will got fire, it will explode. What will happen? What do you guess? Your guess? What do you think? Come on, anyone?
Sir, can you please repeat the question again?
Question is, as I said, that depending on the address bus, you have maximum capacity of the memory. If you have 32-bit address bus, theoretically, you can have maximum 4 gigabytes for 4 gigabit of memory, all right, based on the address bus. My question is, what will happen if you use 8 gigabit of memory with a 32-bit address bus? What will happen? If you use more memory, or if you install more memory than you can use, what will happen? The extra memory will not be used. Okay. Why do you think that it cannot be used? But if I increase the size, then I understand. Fine. Yes, correct. You are correct that if we install more memory than the maximum capacity of that system, you are correct that we actually cannot use those extra capacity because it is our maximum capacity is 4 GB, so the rest of the 4 GB will be unused. Second question, why? Why do you think that 32-bit address bus has maximum 4 GB of memory? Why? I just said and showed you that if the address bus is 32-bit long or 2-bit width, then our maximum size will be 4 GB. What is the reason? Huh? What do you think? What is the reason? Why? I have a bad habit. I have a bad habit that I always ask why. You should also have this bad habit. Why? Why and how? Okay, you should say, okay, we understand. Thank you that yes, it is related to the address bus, to the main memory capacity, but why and how? Do you have any guess that why and how? No? Remember, I have showed you that about in the calculator 2 to the power 32, right? 2 to the power 32 is the 4. 2 to the power 32 is the 4 giga, right? So that's why it's the 4 giga. Why I did 2 to the power 32? There must be a reason, right? Why I put 2 to the power 32 and it is a 4 giga. Whenever I put 64, it is now almost 2 tera. Why I use 2 to the power that number? Why? Because we know that we have a binary system, right? 1010, right?
Yes.
Whenever we have a width of an address bus of 32-bit, just imagine that in address bus, right? So how many combination is possible if you have 32-bit? It is a binary number. 2 to the power 32, right?
Yes, sir.
2 to the power 32. Whenever you have 32-bit binary number, how many combination possible? 2 to the power 32. So 2 to the power 32 means actually nearly 4 giga. That's why each of the combination locates one of the memory block. That's why we have 4 GB of space of the memory. That means we can have 4 GB of different memory blocks. But if you install more than that, we will not have any address for the rest of the extra block. That's why we cannot use them. Same way, whenever you have 64 bits of address bus, how many combination is possible with this 64-bit address bus? 2 to the power 64, right?
Yes, sir.
Just imagine like 1010101010, 64-bit long. How many combination possible? 2 to the power 64. That means you have 2 to the power 64 different types of memory block address. That's why 2 to the power 64 means almost 2 tera. That means you have almost 2 tera of different memory block, which is a 2 tera megabit of memory. That is the relationship, and that is the reason that we have a relationship between address bus and the maximum memory size. Do you understand now?
Sir, why we use 2 in the base? Why not 3, 4, and other
Because
numbers?
it is a binary number.
Yes. Computer only works on 0 and 1.
The binary number, yes. It is a binary number because whenever you have a binary number, for example, you have 3 bits of binary number, right? 0, 0, 0, 3 bits. How many combination possible? By 0 and 1. You have 3 bit number, binary number. How many combination possible?
Sir, 8, sir. 2 to the power 3.
2 to the power 3, right? Because it's a binary number. We have only 2 options, 0 or 1. Right, 0 or 1. That is the option we have. So we have 3 position. So for the 3 position, it is a binary number. So the thing is you have combination 2 to the power 3. That means we have 8 different types of combination. For example, 0001, 010, 011, 011, like this. Okay, that means we can have maximum 2 to the power of 3 combination because it's a binary number. Same way,
Yes, sir.
this is a binary number. This is a binary. Of course, our system is binary. That's why whenever you use the address bus, we have 64-bit long or 32-bit long. That means at a time we can give 32-bit data. That means we have 2 to the power 32 different types of address, or 2 to the power 64 different types of address. That's why we have 4 GB or 2 tera maximum memory.
Yes, sir.
Fine?
Yes, sir.
Just think about it. Very simple. Very, very, very simple. If you just think a little bit, should not have any confusion right now. All right. So that is our, yes.
Sir, actually, I have another thoughts and questions, sir. Now we are using the address bus 32-bit or 64-bit is common nowadays. In future, if we use 160, 124-bit, it will control our internal unit as well. So in that time, do we have provide more RAM or ROM at that time?
Yes, of course. It depends, of course. Why we have, wherever, for example, why we are shifting. What do you think, everyone? What do you think? Why we are shifting from 32-bit to 64-bit? Why? Of course, because if you are using 32-bit, then we can have maximum 4 GB of memory, which is nowadays is nothing, right? It's nothing. So we need to upgrade ourselves from 32 to 64. That's why we have upgraded. In the future, of course, we will upgrade from 64 to 128. Why not? Of course. In that case, then you have to change your system as well. We will have more memory. We'll have separate types of processor. So the more the time passes, obviously, you are going to see the more width of the address bus and the data bus as well. Most of the time, the size of the address bus and the size of the data bus are same. most of the time. If the address bus is 32-bit, your data bus is also 32-bit. If your address bus is 64-bit, your data bus is also 64-bit. Most of the time it is same. There are some exceptions. There are some exceptions that they are not same. I will show you into chapter number 3 whenever we are going to discuss about the processor. In that case, we will see some of the history of the previous Pentium processor. In that case, we will show you that some of the processor does not have the similar types of bus. But in general, just remember that most of the time, the size, the width of the address bus is the same as the width of the data bus. All right? Simple. But this is not a universal rule, by the way. As I said, there are some exceptions. Fine? Okay.
Sir, I understand, sir.
Yeah, okay. So, so that is our address bus and the data bus. Let us see about the control bus. What is the control bus? Remember, this system bus is a must question. In all of the exams. First term, midterm, final, theory, assignment, Viva, and everything. So please make sure you understand it very nicely. Okay, let us see about the control bus. So about the control bus, there are some controlling signal, as I said earlier. These are the controlling signal. These are the controlling signal. You can see that the control bus consists of a set of control signal, includes memory read, memory write, input output read, input output write, interrupt acknowledgement, bus request, and other bus grant. Right? These types of special controlling signal we use for different types of activity. For example, if you want to read from memory, right? Let's say you want to read an instruction from the memory, all right? Then the control bus, the processor gives a control signal in the control bus that it is a memory read. So the status of this execution should be memory read. So based on the control bus control signal, the other process will work. So if you want to read from a memory, we are going to show you the step-by-step process that how we are going to read and write from the memory. Just for your knowledge right now, very simply that if the processor wants to read anything from the memory, he first of all, he put the address of that memory location into the address bus and then update the control bus control signal as a memory read, right? And then processor gets the information from that specific memory location and put it into the data bus. All right? And then you can process that data. That is the overall simplified way how we can read from the memory. If you want to write into the memory, again, same thing. The processor needs to put the address that which memory location you are going to write, change the control signal in the control bus. Okay, now we are going to do write. So it should be memory write. And then we are going to write into the memory and put the data into the data bus so that it can send the data into that memory to write it. And then we can write the data into that memory block. So these are the step-by-step procedure we follow to do different tasks by using all these three bus. Different bus has different responsibility. Fine, do you understand about the control bus? Any question? Okay, interrupt. Okay, interrupt means whenever processor is doing something and there are sometimes you have to stop, right? And go to the other process. That is the interrupt. Interrupt acknowledgement means you have to send an acknowledgement, a confirmation. Acknowledgement means confirmation that yes, I have interact, and then I pass to another process, or another going to the another process, and you send an acknowledgement. Acknowledgement, the confirmation that yes, I'm doing it. Right. Bus request, same thing. You have to, okay, bus request means you need to get permission to use the bus sometimes. So that is called bus request. You have to request it. Okay, I want to do this job, so let me use the bus for this specific time. That is the bus request. Whenever the processor gives you the permission that yes, now we can use the bus, it's actually saying the bus grant. That means yes, is now the permission. This is the permission. Now use bus. That is the bus grant. Right? There's so many others. I know that we know that processor effect. So anything and everything you want to do, it goes through the processor. Same as our brain. Anything and everything we try to do or think to do or want to do comes from the brain, and then it comes to our other activity. Okay, so that's how we need a lot of permission, a lot of calculation, a lot of analysis and everything. It's quite interesting. If you, the full computer system is actually the similar as our nature. If you think about the animals or the plants, same thing. By the way, off-topic question: do you think that the plants has their own intelligence? We have our intelligence. The animals have their intelligence. Let's think about a tree. Do you think that a tree has its own intelligence?
So I think so, because they move around like some millimeters a year. Yeah, I think.
So you think that the plant has its own intelligence, right?
Yes, and they also mutants.
So they don't have any brain.
I don't know about that.
Think about animals. They have a head, they have a brain. Our computer, they have a processor, which is their brain. How about the plants? They don't have anything like that. Then how they think, how they take decision? Who control the decision? Who takes the decision?
I think, sir, it's about the cells.
It's about the cells. Yes, correct. It's about the cells. It is the best example about the viruses. I think you know that now our coronavirus is actually changing so many times by itself, right? Like Indian variant, like other Nigerian variant, like the other variant. So what are these variants? The alpha, beta, gamma, delta variant. So these kinds of variant means the virus, whenever they attack a human, and the human takes some necessary steps about the vaccine, and the virus also, to fight with the vaccine, they change themselves so that they can fight back against the vaccine. That's why they have changed so many times by themselves. Think about it, it's a virus, very, very, very small, object. But it has that much capability to adapt themselves. Much adaptive compared to us as human. Nowadays, humans are not adaptive, cannot adapt. Sick, it's too hot, they also got sick. If something else, they got sick because we're not thought adaptive. Previously, we were so adaptive. That's why nowadays we are so weak. Anyway, off topic. Don't worry. I'm just thinking because it's quite interesting. It is quite interesting to me that we are thinking about the artificial intelligence. Right? We are thinking, we are working, we are studying about artificial intelligence. We have natural intelligence, but we are using artificial intelligence in our robot. in our IoT system, in our computer, machine learning. So into the machine, our smart car, our smart everything. So how about the plant? How about the virus? They're much, much more smarter than us. The nature itself, much, much, much more intelligence than we have, than we claim that we have. We don't have any intelligence at all. We can just destroy it. Anyway, off topic. Don't worry. Anyway, let me give you the attendance first. It is quite interesting to observe my 9-month-old daughter. When she first born, from that day and until today, I actually just observed that how she is learning about everything. That is the intelligence. That is the natural intelligence, which we can use in our artificial intelligence. Did you watch a movie called Chappie?
Yes, sir.
Science fiction movie, a Chappie, a robot?
Yes, sir.
Yes,
Yes, sir.
They're making a robot and they teach the robot from like a baby until whenever the robot can do everything, right? That is the process. That is the process you can develop the intelligence. And that is the best example I can see when I observe my daughter. She learning every single day, every single hour, that how to grab, how to do, how to stand, how to walk. Like it is an intelligence. And that's how we can train our robot. That's how we can train our machine to make it intelligent. And that is the artificial intelligence. It's quite amazing. For me, it's quite amazing, by the way. Anyway, your section is C. Really quite interesting. Artificial intelligence. I have learned artificial intelligence long ago, in 2004-5. Now, when I was today, I'm in this. So CSC-197 section C, please respond. Shakil Ahmed. Mominur Rahman.
Yes, sir.
Saidul Islam.
Yes, sir.
Moinul Islam.
Yes, sir.
Islam is fine. Shariar Haq.
Yes, sir.
Kazimul Haq Rani. Mukit Hassan.
Yes, sir.
Said Itul Islam.
Yes, sir.
IMD Shubujur Rahman.
Yes, sir.
Gon Kumar Dash.
Present, sir.
Mit Hassan.
Present, sir.
Rubel Babu. Mr. Rubel Babu. Rizwan Ahmed.
Present, sir.
Jannati Naim.
Yes, sir.
Imtiaz Tasnim.
Yes, sir.
Shahida Ahmed.
Yes, sir.
Sadia Akhtar.
Yes, sir.
Afia Siddiqa.
Yes, sir.
Rahul Debnat.
Yes, sir. Yes, sir.
Abdul Sabur. Fine. Abdul Sabur.
Present, sir.
Rohanul Kabir. Rubai Alo. Rohanul Kabir.
Yes, sir.
Alright. By the way, Mr. Rohanul Kabir, you have a group, right?
Sir, no. You
Why no?
said that you three guys make a group.
So you can have the last group, which is 15. I think nobody else is in group number 15. Group number 15, submission date. Doesn't matter when you have a group or group
Sir,
number.
group number
It is
15.
was yes, because group there is no one in group number 15. So if there is anyone like Mr. Rohan Kubir that doesn't have any group, so please join in group number 15 because it's empty right now. All right, and start work, please. Because your last date is start apply. Okay. All right. Next
Yes,
one.
sir. Yes, sir.
Lamia Akhtar. Sumaya Islam. Absent.
Yes,
Amin.
sir.
So slow. I think your processor is like 16-bit. Fahim. Abir Hassan. Hussein. Abir Hussein. Fahim bin Shahid. Absent. Muhammad Babu Alam. Johura Akhtar.
Yes, sir. Jurat Tamim.
Right.
Yes, sir.
Nushin Tasnim.
Yes, sir.
Jafar Islam. Sharia Shimon.
Present, sir.
Shargop.
Yes, sir.
Ashikur Rahman.
Satu Shargup, sir.
Fine. Ashikur Rahman.
Yes, sir.
Jannatul Firdaus. Tahmina Nasrin.
Yes, sir.
Tahmidur Rahman.
Yes, sir.
Kaya Jannat.
Yes, sir.
Rakibul Hassan.
Yes, sir.
Sabiha Parvin.
Yes, sir.
Mehdi Hassan.
Present, sir.
Al Amin Akash. Mr. Al Amin Akash.
Sorry, sir. I have a problem. I am present, sir.
Yeah. Abdus Salam.
Yes, sir.
All right. So 5 of you are absent.
Sir, Moinul Islam, sir.
Sir, probably you missed my name, sir. You didn't call me.
What is your name?
Sir, Himal,
Huh?
Moinul Islam, sir.
Moinul Islam.
sir, Himal Shakar also.
Moinul Islam is fine. Even Shakar is alright. Fine.
Thank you, sir.
It's alright. Fia Siddiqa. I think it's fine, Fia Siddiqa. It's okay. Alright, thank you. Let us continue because we still have time. One more thing, not about the course. Please, select one course, not course, class representative or whatever you call, because sometimes it is difficult to respond all of you in some of the issues. So please select one junior, senior, junior, boy, girl, doesn't matter. One class representative where make sure that you know most of your friends or classmates, and you should be available. All right, and you should have a very good understanding with your classmates. Okay, please select one and let me know. One or two, whatever, doesn't matter. All right, I just need minimum one. So please select one and let me know your name, ID, and your phone number. Next time, if you have any problem, talk to your team leader or class representative first, instead of calling me at 10 o'clock at night. Unusual, unsocial. All right? You understand? Please select one or two. If you think that one boy, one girl, up to you. Or if you just think one will be enough, then one, no problem. But please select, all right? And then you should talk to your class representative first before you contact with me. Okay? Better for you, better for me as well. Okay? Any questions so far? Now we have, okay, we're not going to discuss anything, but just to revise that what we have discussed so far today is about our
Sir, our class time is over.
It is 2:15, right? No?
No, sir, 2:10.
Or 2:10. Oh, I'm sorry.
10, yes, sir.
I'm sorry. Anyway, then thank you very much. I'm sorry. Thank you very much. See you in the next class then. Allah Hafiz.
Assalamualaikum, sir.
Walaikum assalam.
Assalamualaikum, sir.
Allah Hafiz. Thank you.
Assalamualaikum, sir.